Algebraic representations of transformations. How can you describe the effect of a translation, rotation, or reflection on coordinates using algebraic representation? So what we're talking about when we talk about an algebraic representation is shorthand. In our shorthand, we're going to use symbols, variables, and numbers. These are the things that are going to make up our algebraic representation. By using this, we won't have to say by words what's actually happening. We can use the shorthand to describe what's going on. Now let's remember that a transformation is an image change that describes a change in the position, size, or shape of a figure. We're going to take these one at a time, so we're going to first start with a translation, which is a slide. Now we know that a slide of a figure to a new location is called a translation, and that's when we take something and slide it left, right, up, and down. So the X is going to move to the right when we add something, and if we're going to subtract something, we're going to move it to the left. The same is true for the Y, because the Y operates up and down. So if I'm going to add to the Y, it's going to move it up. If I'm going to subtract from the Y, it's going to move it down. Now, how does that help play out in our format? Well, our format's always going to start the points. Here we are, X, comma, Y. That's the point. Is going to change. That's what this means. The point is going to change. And when we do a translation, we're going to put in parentheses X, and depending on what's happening, is it being plus, is it being minus a certain number, comma, and the Y plus or minus a certain number. So this is the format we're going to use. Now what we're going to do is kind of practice this here a second. So let's take a look and see how many spaces did this translation move. So we want to go from A to A prime. So in order to go from A to A prime on the X, we have two things we did here, right? The X and the Y. So let's talk about the X. We went 1, 2, 3, 4, 5, 6. We went 6 to the left. And then on the Y, we went 1, 2, 3, 4, 5. We went 5 down. So now what we want to do, instead of using words, we want to use that notation and see if we can come up with something. So let's write the point, XY, is going to change. How is it going to change? We're going to take the X and we want to go left 6. So that means we're going to minus 6 because we're going to the left. And then we want to go down. So we're going to take the Y and we want to go minus 5 because we want it to go down 5 units. And that's how we would write when one thing changes to another. Now let's practice doing something a little different. What if I told you that we're going to take the point XY and we're going to change it by this? What this is saying is take the point XY, which would be this one up here, this point A. And what we're going to do from here is we're going to go positive 3 on the X. So 1, 2, 3, and positive 1 on the Y. So that's going to relocate that A prime right there. Okay, and the same thing would be true for E. Positive 3, 1, 2, 3, positive 1. So we would do that to each point until we redrew it over here, and I'm drawing a little bit off my chart, but that's okay. Same thing for C. 1, 2, 3, and up 1. It's the same one here. 1, 2, 3, and up 1. And so this would be the location based on this shorthand. It kind of tells us where we're going and what we're doing. Okay? All right, now let's take a look at a reflection. Now, we know that a reflection is a flip of a figure over a point or line called the line of reflection. So let us talk about a certain point here. Let's take one point at a time. We'll talk about point G here. Now, if I was going to reflect across the y-axis, so here's the y-axis here, and I'm going to take this G and I'm going to flip it to the other side. I notice that it's 1, 2, 3 away here, so I need to go 3 away on the other side. 1, 2, 3. So make that G prime. Now what I want to do here before we continue and do the other points, I want to write down what the coordinates here. We have on the G, we have 1, 2, 3, so positive 3, and 1, 2, 3, 4, positive 4. And on G prime, we have 1, 2, negative 3, and positive 4. What do we notice about the variable changes? Well, the 4 stayed the same, didn't it? And that makes sense because it pretty much shot straight across, didn't it? Didn't change on the Y. But the X changed. It changed from positive to a negative. Okay, so we know that when we are going to reflect across the y-axis, we're going to make sure that the x value goes from a positive to a negative. Okay, and the same thing is true then about what happens when we go across the x-axis. So if I had, for example, this triangle here, and I want to go across the x-axis, I want to take it from here and come all the way across this direction. So this, let's say this point here, way up there, okay, and that would be -1, and then we would go 1, 2, 3, 4, 5, 6, 7, 8, +8. If we were to take this triangle and flip it all the way over to opposite on the x-axis, we would look something like this. There's our triangle. Okay, and so this point now is still going to be -1, but now it's going to be -8. So what happened this time? This time the y changed. So when we're flipping over the y-axis, the x-axis, the y is what changes its value. When we flip over the y-axis, the x is what changes its value. So we want to kind of keep an eye on that so we know what's changing. So what's the algebraic representation for this reflection? Well, since this reflection is going across the y-axis, and if you forget which one to make negative, what you can do is sit here and start out saying, well, nothing changes, but something really does. We can take a look at a point. Take a look at G and look at G prime. Here, it's the x is positive and the y is positive. Here, the x is negative and the y is positive. So the one thing changes is that the x changed. So you can put a little negative x sign there. And so this is saying take the points of the figure, change them so that the x's are now negative and the y stays the same. That's how you write the shorthand for a reflection. Now let's talk about a rotation. Now rotation is interesting. There's a lot of different ways to do this. And so let's take a look at one first. We know rotation is a turn of a figure about a point. The turn is counted in degrees and stated by direction, and we call this the angle of rotation. So let's kind of take a look at this little point that I have here. And this point here is 1, 2, 3, 4, 5, 1. And this point, when it rotates, and let's rotate clockwise. So let's go down to here. It would rotate this direction, right? If we're going clockwise, we're going here. So now this point has become 1, 2, 3, 4, -5. If I rotate it again, it's going to be out here, right? And now it's going to be -5, -1. And then if I rotate it one more time around, right here, it's going to be -1 and +5. So what do we notice about the variable changes? What's going on? Well, let's go from the first one, and let me letter these a little bit so we can have a discussion. A, B, C, and D. We can see when it went from A to B, what happened was the positions changed. The 5 that was in the X spot went to the Y spot, and it became negative. So doing a 90-degree rotation clockwise will make that occur. What if I decided to go 90 degrees counterclockwise? What if I went that direction? Well, the same thing. The X and Y's changed places, but this time, because I went counterclockwise, the X is what gets the negative sign. So clockwise, the Y gets it, counterclockwise, the X gets it, and they're always switching positions. But what's the relationship when we go 180 degrees, when I go all the way around to the other side? Well, they stay the same place, X and Y, 5 and 1, but now it's -5 and -1. So we're going to keep them exactly the same, but we're going to make them both negative. So let's kind of write all that down. Now remember, this format only works when we're rotating about the origin. So once again, we're going to go 90 degrees clockwise from the origin. So in order to go this direction, we're going to say that our point, XY, we're going to switch it, Y, comma, -X. When we have the format for going 90 degrees counterclockwise around the origin, and counterclockwise is over towards our left, we're going to take the XY and we're going to change it. And again, we're going to switch the places around. but we're going to make this time negative y and a positive x. Our format, when we want to go all the way to the other side, we want to go 180 degrees all the way over to the other side. We're going to take the original point, and not only are we going to make them negative, both are negative, negative x and negative y, and they're not switching places. So these are kind of hard to remember, but if you remember that little thing we just did here a second ago with I'm going to go back a second, with the points, and you can do that. Find out where it is and see what's happening, and then you can decide what the shorthand is. So let's write some algebraic representations for these rotations. Let's try one more time. So if I wanted to go 90 degrees clockwise around the origin, I'm going to take my point xy. And remember, pick a point. Don't pick this one that's 1, 1, because that one's going to stay in between. It'll get confusing. You want different numbers. So we know this one on the outside is positive 5, positive 1. So we're going to take that point, and we're going to go clockwise, which means it's going to drop here. We can see that the y that was originally here is now going to be in the x spot, and the x is going to go in the y spot, but it's going to become negative, so we're going to drop a negative sign there. If we were going to go 90 degrees counterclockwise, we would take our point xy and we would change it. Going counterclockwise, that point now comes way up here. For it to go way up there, that means when it was originally a 5, now it's at negative 1, we're going to take the x and put it here. Remember, they're going to switch positions, so it's going to become negative y, and the x will go in there. So again, see how they're both switched, but different ones are negative depending on where you're going. And that sounds right because we're coming up here, and we're going to have negative 1, positive 5, so we can see the switch in it. Now, last one, if we're going to go 180 degrees counterclockwise about the origin or all the way around to the other side, that swing point that's on the outside is now way over here. And basically we're keeping the numbers exactly the way they are, take them the way they are, and we're going to keep them exactly the way they are, except we're going to make them both negative. So you kind of notice that we've got at least one negative happening, maybe two, a little bit different than reflection, but if you pick a point and see what's going on, it makes it so much easier. I hope this helps a little bit with algebraic representations.